Hello, everybody, and welcome to this live session on September 29th. We are almost at the end of Azure Back to School for another year. This is our last live stream. We have a couple pre-recorded videos for the 30th, which is great. But I want to welcome Nikos today to talk about orchestration in Azure Functions, but how to lead the orchestra. So we're going to be a conductor today, it sounds like. So I will turn, very excited to hear this presentation. So without any delay, I will turn it over to you, Nikos. Have a great session.
Thanks, Dane. Hello, everybody, and thanks for having me at Azure Back to School. Today, I am going to talk to you about how to orchestrate or how to make them play together, those Azure functions. Before starting, a few words about me. My name is Nikos Delis. I work as a senior cloud engineer and cloud evangelist at Helo, Swedish company. So I am based out of Malmö in Sweden, Europe. I am in social media. You can find me on LinkedIn and on Twitter or X if you may prefer. And I also have a technical blog where I try to share everything I consider not to be common knowledge. I also do a podcast called Azure Triumphs, stories of people who succeed with Azure. And there I have the joy to have as guests brilliant people who share stories about Azure, but recently not only Azure, even career advice, even stuff like that, always related to the Azure and the .NET product family. I have a few certificates, and I also try to be as active as I can in various Azure communities. If you want to meet me live, then just join any session of the Azure Skåne community, which is the Azure community based out of the Malmö region in the southern Sweden. But enough about me. Let's take a look at today's agenda and what we're going to be talking about today. So I will keep this session very basic, and I hope that everybody will have the chance to follow. And you're very welcome to write any questions you have. I will try to answer, if any, at the end of the session. So today we're going to talk about serverless computing and Azure functions, like what are those things and when do we use them, why do we use them? And then, of course, I'm going to talk about Azure functions and even about durable functions, which is a type of Azure functions. Then I'm going to show you a few ways to orchestrate those things, to make them play together, and why you should do it. Last but not least, I will try to present a few best practices and also some pitfalls to avoid if you don't want to have bad experiences with Azure functions. And of course, there is going to be some time for question and answers at the end of the session. So, with that said, let's do a fast recap about Azure functions. Well, I guess that if you're attending my session, then you already have had a little or some more experience with Azure Functions. And Azure Functions is Microsoft's take on serverless computing, or one of those. And what you get by using them is that you have the cloud service provider managing the server for you, so you do not have to deploy any virtual machines. You do not have to worry about installing any runtimes. The cloud service provider, and in this case Azure, is going to take care about all of that. Then, of course, you don't only get those, you also get scalability and distribution, meaning that you are going to get as much resources as you need, and this is good because you're only going to pay for as much resources as you need. And of course, it gives you a fast link to production. There is a very straightforward way to create and deploy them, and you can do it Of course, it's preferable if you can do it with pipelines, no matter what you use, GitHub, Azure DevOps, or whatever you're using. And of course, you can use bicep files, or you can use Terraform, or any kind of provisioning you prefer. And of course, the big reason of using Azure Functions when you can is that it is going to turn out very cheap in most cases. And this is because an Azure function is only a piece of code that is going to be executed on demand. Actually, it's going to be executed when a certain event is triggered. So the Azure functions, if we look a little bit closer on the product itself, and why they are good. Of course, as I mentioned earlier, it is Azure's take on serverless computing. Others have other. I know that the AWS has their Lambda functions, and GCP, the Google Cloud, has also something similar. I'm pretty sure about that. Azure functions can be written in quite many languages. C#, F#, JavaScript, Java, Python, to name a few. Go, I also believe is supported. And this is a great advantage. This is a really good thing because you do not need to rewrite all your code if you're migrating to the cloud and you already have maybe some app services or some web apps which you are going to maybe break down or make some microservices out of them. Then Azure Functions are fantastic to use if you want to create microservices. Of course, we have triggers and we have input and output bindings. By input and output bindings, I mean certain things that can be used as input of the function and, of course, as output of the function. The triggers, the difference between a trigger and an input binding is that the trigger is going to get the function running, while the input is going to be something that the function gets with it when it starts. So we could have a blob trigger, and we can have a blob as an input binding also, meaning that the one will get the function to start and the other is going to be available in your code when you start coding. Of course, the Azure functions are integrated with multiple Azure services. I can name the Azure Service Bus, which has the Azure functions have a specific trigger, which is used if you want to execute a piece of code upon receiving a message on the Service Bus. Also, in many IoT scenarios, we have the IoT hub has an event grid, and we have an event grid trigger, so that an Azure function can fire when you get a message in your IoT hub. And even, of course, the API management, the central resource that Azure uses to manage APIs. You get the Azure functions in the backend there. If you want, and they're very handy. And of course, as I mentioned earlier, if I was to design any microservice architecture in Azure, Azure Functions would be a no-brainer for me. I would use them any day a week. And then, last but not least, we have the durable functions. And before explaining in detail what the durable functions are, let's explain why we need them. Now, I said many good things about the Azure Functions, but there are some less good things also. And one of those is that the Azure Functions can only live for a certain amount of time. And during this amount of time, we have to be done with our workload. And if not, then what do? We use the durable functions. And as I said, I'll talk more about this later, but there are also some other things that we need to be careful about. The timeout is one of them, and this is which is exactly what I mentioned at the beginning. And this is different in the different tiers. In consumption tier, we have, if I'm not mistaken, a few minutes, and then in premium and dedicated tier, we have much longer. Then again, if your function needs to be running for an hour or so, then maybe maybe you should consider other solutions as well. Then the scaling is something that you need to be very careful about, because if you want to, if you want to implement the first in first out architecture and you have automatic scaling in Azure Functions, this means that another instance of your function could be started without you wanting it. And then this means that who picks the methods? Well, it's we can't say for sure. So if you need to implement the first in first out scenario, then you need to make sure that you only have one receiver there. Another thing that you have to take into consideration if you are planning to use Azure Functions is that you are going to have some cold starts. And by cold starts, I mean that the Azure Functions are applications, like all the other applications that Azure is running for us on shared hardware. And of course, we don't want to pay for what we do not use, but what is going to happen is that they're going to sleep. Of course, they're not sleeping, they're closed, or yeah, let's say that they're sleeping, and the first time that we need them, we have to wake them up, and this will take a second or two. So this is what we call a cold start. That the first call after a while is going to take some milliseconds. It's going to take maybe a second or two also. And you need to keep it into consideration. Now, you can avoid that if you go to a higher tier, but of course, the higher tiers cost more. I have also had, a bit stranger experiences trying to debug the Azure Functions. And keep in mind that if you are in premium and dedicated tier, then you also have much higher networking capabilities. So it's not impossible at all that your function is behind a VNet, or that you have some weird stuff going on there. And then it's not that easy to debug them, because you cannot. It's more challenging to connect the Visual Studio or whatever either you're using to the running function. So it is a possibility you can debug a deployed Azure function, but it's not as easy as it sounds. Then when we run anything actually in shared software in someone else's infrastructure, then they are the one who manage it, who control it. And this means that in order to keep us safe and in order to offer us the bleeding edge of technology and the best thing there is, they are going to keep a certain amount of runtimes available and versions of runtimes available. So one thing that you have to keep in mind is that you're not going to have access to .NET Framework 3.5. Example is now that's already dead since years ago. But what I want to point out is that the runtimes have an end of life. And when this end of life comes, then Microsoft is not going to support them longer. And you're not going to be able to deploy, and you will have to upgrade your functions. Now, someone might say, but is this a bad thing? No, not at all. Actually, it's not a bad thing. But you have to keep in mind that this is up to you, that you have to make sure that your functions are up to date, that you have to make sure that you're using runtimes that are still supported by Azure. And of course, you're going to get lots of notifications, and they're going to let you know at least a year in advance before they remove support for runtime. But it is something that I would keep in mind. Then, last but not least, it is very cheap, especially in the consumption tier. In most scenarios, you get by paying almost zero, but it can be very, very expensive if you're not careful. So, example wise, we use Application Insights. This is a very good resource for your logs to be saved and presented, and it is a great tool. if you want to have control over your application, to see what's happening and all the log messages and stuff. But if you misuse it, then it's going to cost a lot. I have had a scenario when we bombed it so badly that it got really expensive, and I will talk about that later when we talk about European functions. But what I want you to remember is that it's not totally free, and you get a lot of runs for free, and even in the consumption tier. But after a while, it costs, and it can cost a pretty penny. So be careful with that. So I mentioned some pros, I mentioned some cons. So the question is, when should we use the Azure functions? And there are some scenarios where the Azure functions are kind of a no-brainer. And also there are some scenarios where the Azure functions are not the best solution, at least according to me and to my experience. So first of all, if you have deterministic tasks and stateless tasks, and a deterministic task is a task that gives the same output for the same input, then Azure functions are great. If you're doing event-driven computing, then it's a no-brainer. They have so many triggers. You can run an Azure function when a file appears in Azure Storage. You can run an Azure function with an HTTP trigger, meaning that you can just send a post request and the function is firing. They are fantastic if you're building microservices. Sync responsibility, everything is great with them. If you have legacy resources which you want to move to the cloud, and they're not written in C#, even there, having support for so many languages, the Azure functions are great for those scenarios. Then there are some scenarios that are less appropriate for Azure functions, the long-running applications. If you have an application that is constantly running for some time, then maybe you should consider a usual app service. If you have heavy-duty tasks, like with high IM and CPU there, sorry for the typo, and high memory needs, then maybe you should consider something else, because there are multiple tiers and you can get optimized resources for your scenarios, but the Azure functions are meant to be little, delegate, robust. They're meant to be executed very quickly and then be done and go to sleep. So if you really have heavy-duty tasks, then maybe you should consider another type of resource. And of course, if you need to host a whole web application with a GUI, with a graphical user interface, and like a full-fledged application, then I wouldn't use Azure Functions, at least not for the front-end parts. You have the static web apps, you have the usual web applications. You can use anything like those. Of course, I would use Azure Functions for the backend part, and especially if it was a microservice architecture, but not for web applications. I wouldn't serve HTML via an Azure function. Now, getting in the main subject of my session. I don't know how many of you like football and how many of you recognize the gentleman there. This is Eric Cantona, and in his series Jogo Bonito, he said, "You can sing like the canary, you can be a virtuoso, but believe me, you can only make beautiful music if you know how to play in an orchestra." This is said by Eric Cantona. And I want to show you a few scenarios where combining multiple Azure functions, we can do magic stuff. And I will also make sure to show you what we win with those orchestrations. So the first one is decoupling. Now, what exactly is decoupling? I think that the name speaks for itself, actually, but let's explain it for a minute. Decoupling means that instead of having, like I saw you here, instead of having two resources talking directly to each other, we put something in the middle, and hopefully something that will stay alive for a long time, something that is not depending from one or the other. And why would we do that? Well, we would do that to remove the dependency. Now, in this scenario down here, when an Azure function calls another, and that might be a user HTTP request, after all, it's like any API endpoint, then for this to work, for this function to be able to keep its responsibility, it depends on that function being alive, being responsive, being up and running. Now, if we don't want to, or if we can't count on that function being available, what we can do is that we can break the couple, we can decouple them, and we can do it in various ways. The one that I will show you today is using Azure Storage. So instead of this function asking this function to do something, this function will put a blob, a small file, into Azure Storage, and this one will have a blob trigger, meaning that it will only fire when a file appears in Azure Storage. So we're going to achieve the same functionality, but this time we do not have any dependencies. The next example I will show you is the one of function chaining. Now, this is exactly the opposite of what I showed you here. So I'm doing it on purpose. I know that this is not optimum, but I want to show you that we can use function chaining in order to break monoliths. So instead of having one function doing all the stuff, you can break it down in smaller portions, and you can ask the functions call each other. Now, as I said before, this is not really the way to do it. We're going to use durable functions to do that. But the orchestration, the architecture behind it is actually the same. That when this is done with this job, it calls this one. And when this is done with this job, it calls that one. And so on and so forth. And why do we do that? We do it to share the part of the job. So we don't, instead of having a monolith, instead of having one function doing a lot of stuff, we break it down and we have multiple functions doing multiple of tasks. The third one, and the one that I am unfortunately not going to show you in a demo today, is the one I actually use the most, is using a service bus. So the icon you can see here, it represents Azure Service Bus. It's Azure's message broker. And yeah, this session is not about Service Bus, but let's say that it is a kind of an application that can get messages like the ones you can see here. And people publish the messages to the service bus, and the service bus makes them available either in queues or in topics. And the main difference between a queue and a topic is that the topic can have many subscribers. So if you have a queue, then you have a single sender and single receiver. If you have a topic, then you can have multiple senders and multiple receivers. And actually, they're not receivers because nobody is receiving anything. What is happening and why the arrows are going in both directions here, I hope that this is visible in all of those functions, is that the message is published in Service Bus, it becomes available, and via a trigger, a Service Bus trigger, the Azure functions pick the message, and then you can configure it as you want. But usually, the first function that picks the message is the one that completes it also. So it's not available in the same topic for more functions. But you can have multiple topics and you can have multiple listeners. And then the message is being available in every listener. So let's go on and take a look on the first orchestrations that I mentioned. Now, I have written some code, and I will show you here. I will try to zoom in. Hopefully, it is the code is visible here. I'm 160%. So this is decoupling, and I have two functions here. The first is called create blob, and it has an HTTP trigger. It is going to be triggered by a usual HTTP request. And the second one I have has a blob trigger, meaning that it is going to listen, it is going to await until a file appears under the blob container that is called Azure Functions demo. So if I run this one here, decoupling, yep. Then let's see what happens. I will try to keep everything visible for you. Okay, so now what I got is that my functions are available here, and I can just click on that and trigger it. But before I do that, I would like to show you that this is the container and it is completely empty. Now let's keep it here. And now I am triggering the function. I will, in the first run, I will not do anything. I will just trigger the function. So now, as I can see here, I get a response that the file was successfully triggered, which is good. And as you can see here, we even got a message from the C# blob trigger function processed the name of the file that was created, and it is test, then the actual timestamp. The file was 27 bytes, and the content was hello Azure back to school. And this is no surprise because that's exactly what I wrote here. That's exactly what the name I wanted to be. And as you can see, if I reload here, then we also have a file here. Now, I mentioned decoupling, and I would like to make sure that this is the most important thing. So let's put a breakpoint here, and let's rerun once again. So as you can see, I have already gotten my response here, and I can run it even more times. Okay, now I'm stuck in Visual Studio. But as you can see here, I didn't get the file yet. The blob trigger has not triggered yet. So if I push continue, sorry, that was a bad breakpoint. Then now I get, sorry, I should zoom in probably. Now I get the file again. And you can see by the timestamp that it is a new file. I can also run it a couple more times, just to show you that this works by itself. So those two functions do not actually talk to each other, but they manage to communicate via middleware. So all those blobs that were created here are the ones that the blob trigger listened to, and it fired, and it opened them, and it printed the content. Now, let's see the function chaining in the bad way. And by bad way, I'll show you exactly what I mean. It looks like that. Now I have three functions. All of them have HTTP triggers. The first is called function 1. The second is called function 2. And the third is called function 3. Now let's kick it and see what happens. Okay, the command prompt does not look very well. I will try to rerun just to get a clear screen. Fantastic. So now I have three functions available, and let's fire the first one and see what happens. Hi, this is number 1. Hi, this is number 2. Hi, this is number 3. But if you see the execution, first, we started with the first, then we started with the second, and then we started with the third. But they were completed in the opposite way. So first was the third completed, then we had the second, 2 seconds almost, and finally we had the first. So, of course, this is not an optimal way to do it, but we did manage to have three functions talking to each other. Now I will use this as a segue to start talking about the durable functions. So let's close all those. And finally, time for the most interesting stack, the durable functions. Now, the durable functions are a type of Azure functions that differentiate themselves from the usual ones, if we may call them so, in some particular ways. And first of all, of course, they extend the usual functions and they are used for long-running tasks. So I mentioned earlier that if you really do have long-running tasks, then maybe it shouldn't be the best thing to use Azure Functions, but then came the durable functions, and they are designed for long-running tasks. Then we have orchestrations and activities, and as I will show you in a second, those are two of the types of the durable functions. We have a secure state management. This is the orchestrator's job. It is to remember exactly what is happening on every stage of the orchestration. Of course, just like the other Azure functions, they as well are available and can be used with all kinds of other services. And we can use them to implement a serverless stateful pattern. So they still are idempotent, they still have to be deterministic, but this time we can have state. And this is what the orchestrator does. And last but not least, we have a special trigger. And before talking about the trigger, let me show you in one slide exactly what the durable functions are. And those are the three things you need to know to create your first durable function. We start with a starter function. This can have an HTTP trigger, it can have any other trigger, and it is used for only one purpose: to register a new orchestrator and a new orchestration, and to, if you want, you can return the orchestration ID. Then in the orchestrator, this is a very special function and it's a very tricky one. What we do is that we ask all the other functions to do their stuff. And actually, you're not supposed to do any other tasks in the orchestrator other than conducting the activity functions. Now, the activity functions are just like usual functions. The only thing that differentiates them is that they have an activity trigger, a durable activity trigger. So you should see them like that one single starter function fires one single orchestrator, which in each turn can fire multiple activity functions. And actually, in my opinion, you should have multiple functions if you have an orchestrator. Now, the reason why I make you think that this one is sleeping is not really because it's sleeping, but because the orchestrator is specially designed to hibernate while waiting for the activity functions. Now, that's a good thing because we don't have to pay for the time that the orchestrator is sleeping. And it's an even better thing because the orchestrator can take a month to complete the whole orchestration. You can have, you can await a timer forever. Actually, it can remain alive forever. There is no limitation on that. And I have some common orchestrations that are very good to know for durable functions. I know that there are more. I have taken those from Microsoft Learn, of course, but I only chose those two because they are the two most simple to understand. They are the ones that I believe, cover most of the cases when durable functions are to be applied, and they are very, very simple to understand to get started with. So the function chaining, I mentioned it earlier, function chaining, and I told you that I showed you the wrong way to do them. So now let me show you the correct way to do them, and upon that I will show you the fun out funny scenario. Let me take out Visual Studio again, and we're done with those. So let's go to durable chaining. And this time we have durable functions. It was very simple to create them in Visual Studio. You just select the orchestration trigger and you get all three functions you need. You get the starter, which is right here with an HTTP trigger this time, and the durable client as an input binding. You get the orchestration trigger with orchestration context, and you even get an activity functions with its activity trigger. So yeah, of course, they put them in the opposite way than the one I showed you earlier. We have the starter in the end, and we have the orchestration in the top, and then we have the activity triggers in the middle. Anyway, what am I going to do with those functions is that I'm going to send a request to the starter, and this one is going to start a new orchestration instance, as you can see here. The orchestration itself is going to ask 10 activity functions. As you can see, I have a for loop here, and I'm going to call the activity function say hello 10 times. And then hopefully they will say hello 0, hello 1, 2, 3 until 10. Now, even if I have a random thread sleep in the activity function, what I want you to observe is that the functions are going to wait for each other. They're going to be executed in that exact order, 0, 1, 2, 3, 4, and so on. So let's execute that. Durable chaining. Again, I will zoom in. I hope that it is possible to read. And let's fire that one. And look what happened. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 is the last. If I reload and execute again, once again, and once again, and once again, I can do it as many times as you want. I will always get them in the correct order. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is because, this is no accident, this is because I wait them inside the orchestrator. I'm not asking the orchestrator to collect all of them and to execute them later, but I am awaiting, meaning that I execute first the one, then when I get the response, I execute the second, the third, and so on and so forth. Now, in some scenarios, this is a good thing. In others, you just want to execute all of them and to say that you're done with the orchestration when all of them are done and you do not care about the order. Now, this scenario is called fan out, fan in, and I can show you the code for this one. The difference between those two is that if you see here, now pay attention to that, I await each one of them. I execute each one of them inside the orchestrator. Of course, I'm going to do it for the others also, but I am executing them directly. The moment I generate them, I execute them as well. Whereas in the fan out, fan in scenario, the only thing I add in my list is a task. So the call activity async method is going to return a task. It's not going to execute the function. It's going to wait for. It's only going to put tasks here. So okay. So the tasks are all going to be executed together when I await all of them. So let's test this and see the difference. Otherwise, the durable functions are exactly the same. So let me zoom in again and execute. And now, as you can see, they were executed in totally random order: 3, 2, 6, 7, 1, 8, 5, 4, 0, 9. Now, why did this happen? It happened because I have a random thread sleep. So each activity function is going to sleep for anything between 0 milliseconds, so not at all, and 100 milliseconds, which is a tenth of a second. So it's not a long time, but they are indeed slipping. So let's do it again. And as you can see, totally random order again, totally random again, totally random. Of course, we don't get the same order in every execution, and this is because we have the randomizer. So what I hope that is being shown here is that we can use this orchestration to execute multiple tasks in a random order. Now, durable functions, and we're approaching the end of my presentations. The durable functions are not without any pitfalls. There are some things that you have to be very, very careful about, and one of them is idempotency, meaning that the orchestrators must be idempotent. They must provide same output for same input, and you cannot have same output if you use daytime now, example-wise. And this is because every time the orchestrator is going to be executed, you're going to get a different value. And if you get a different value, then the orchestrator thinks that it is a new orchestration and it is going to do everything again. But this is what we want to avoid. We want to run its activity function once, or actually at least once. And this is what they guarantee, at least once, at least one execution. Then we have the testing. And we have the challenging part there that they are event-driven and they have those custom triggers. So it's not very easy to test the bodies of the functions. So I guess that integration testing is in order there, and that you can isolate the body of the activity functions, which hopefully is the one that is conducting all the important business, and to test it separately with unit tests. Then, of course, we have the cold starts, and those are just like the other other Azure functions. And we have the network stuff and data latency. And when you are in serverless environments, you have to do with shared infrastructure. They can be misused, and they're not a silver bullet. They will not solve any scenario. And you have to be careful, and you have to know when to use them and when not to use them. Last but not least, and this stands for all functions, we have the autoscaling, which you have to take into consideration. Now, it's a blessing and a curse. It's a blessing because you don't need to worry about it, and it's a curse because you actually have to worry about it, because it can scale out of proportion and to bring high costs to you that you don't want. And I guess those will have to be the finishing words for my session. I would like to thank you a lot for attending my session. I hope that we can stay in touch, and as I mentioned at the beginning, you can find me on LinkedIn by my name, Nikos Delis, and on Twitter or X if you prefer, by the handle ND Technique. Thank you.
Thank you very much, Nikos. I appreciate it. What a great session to close out our live streams for this month. So thank you very much.
Save the best for last.
Save the best for last. There you go. So yeah, thank you very much for joining us today and for being a contributor and a part of Azure Back to School. And thanks to all of I believe we had 66 individual contributors doing 70 sessions this month. 2 more sessions tomorrow. Make sure you go to Azure Back to School.github.io, and you can get the whole schedule. If you missed any sessions, you can go back and watch those and read the articles that have been posted, the live, see the live sessions on the YouTube channel, and as well as the pre-recorded sessions, as well as Nico's session will be on demand and available as well. So, and appreciate all of the traffic and the comments that are being left and likes and everything on the YouTube channel. So everybody's definitely enjoying the content again this year. And I will sign off this live session by thanking everybody that's watching it, that's made this a bigger event every year of the 4 years, and look for year 5 next year to be even bigger. So thanks, Nikos, and everybody
Thanks,
for joining, and have a great rest of your day.
You too. Bye-bye.